Thanks for being here. I hope you enjoy the show as much as I do. We've listened to a lot of very nice presentations from operators, from vendors, and talking about 5G trials. And among all those trials and early deployments, a lot of them actually were talking about macro outdoor deployments for a macro level coverage. So for my presentation, I'm going to zoom into an in-building scenario because that scenario is something that very few operators has addressed so far. And Comba, Telecom, I'm going to do an introduction maybe at the end of the slides. We are an in-building solution experts that we've been providing in-building wireless solutions that covers 2G, 3G, 4G, and moving forward to 5G for 20 plus years. Without too much time talking about how many deployments and trials has been done for 5G, I think you heard about it for many times already. I would like to bring you this very interesting chart from Gartner. So it's actually a so-called hype cycle. If you're not familiar with a hype cycle chart from Gartner, let me just give you a very brief introduction. So basically, when a new technology is created, it gets a lot of attention, and this is the innovation trigger period, which means a lot of media attention and from the general users are really feeling interested into the solution. A lot of discussions and talks in the industry about the solution. And then very soon the solution will reach a so-called peak of inflated expectations. So when one new technology is at this zone, this the peak area, it means the expectation from the public is usually beyond what the technology can really achieve, and also in terms of timelines. And then there will be very soon a drop, and this is called disillusionment. So basically means the technology has, the public has, and the media has soon very quickly found out, okay, the technology is not as fast or as good as people expected. So there's going to be a quick drop of attention, and there will be less people talking about it. But then there will be companies that has really good technology and still developing it to make sure all the applications will be developed. And then in the end, if you look at this, there's a plateau of productivity. That means all the good companies that have gone through all this hype cycle can finally make a production of the technology and make it into real use case. So we look at 5G here. This report was actually released by Gartner in August of 2018. So it's pretty new, pretty fresh. And they actually analyzed 35 technologies, new technologies. And 5G is right here at the rising part of the hype cycle. And if you look at the color of this part, it basically means it's going to take 2 to 5 years for 5G to be realized, to be commercially available. And which kind of align with all the expectations from the industry and also the operators. So we look at the key figures of 5G deployment globally. We actually have seen a very clear trend that C-band, actually below 60, sub-6 G-band, is going to be the majority band that most operators will choose. I think for very simple reasons, it's kind of a global band. A lot of countries will have license to use that band. And also the band, it has ample spectrum to use. So basically it can meet the minimum requirements for each operator to run 5G to meet the key specs and features. Another band that a lot of operators will be using is actually 28 bands. And I think you heard a lot of news about, especially the US operators are going to deploy fixed wireless access on 28 bands, 28 G bands. So that's, so actually this sets the foundation of today's discussion and also the analysis, because we are going to use 3.5 as a primary band for testing and also simulation of the indoor coverage and capacity solution. 5G is use case driven as versus previous wireless technologies, which is more talking about speed, throughput, connected users. So for 5G, we look at the top 10 5G use cases. I quote a Huawei white paper. There's a figure talking about top 10 5G use cases. And actually 7 among all those 10 top most popular 5G use cases happen indoors. And there's also like a very famous research reports from mobile experts talking about in-building mobile evolution and solutions, and saying that more than 80% of mobile traffic actually happen indoor. So this is really a very important market that we need to address, apart from the macro coverage. Let's look at the market insights. A little bit figures showing you what is the current in-building solutions, or how we call it DAS, distributed antenna system. So the market is, well, so basically we are seeing nowadays a very high penetration rate of DAS solution in the market, starting ranging from small to medium buildings to a very large venues, or even like underground tunnels and a lift. So it's basically already there. This is a survey done by a research group to a lot of different enterprise groups. So actually the data that correspondent for this report are all enterprises, they're non-operators. But they've researched up to 7 different type of enterprise owners, and talking about what are the solutions they use for their indoor coverage. Among them, more than 75% actually use distributed antenna system. And there are like 22% roughly are using other technologies, so it ranges from Wi-Fi, small cells, or just outdoor penetration, basically poor coverage and poor capacity. And if we look a little bit more down to the details at what kind of solutions or technologies we use for indoor coverage, we'll still find out the majority one that is being used is actually passive system. I'm going to show you a diagram on the next slide talking about what exactly is passive system. And then the second popular one will be a hybrid system. So it will be exactly look like this. A passive DAS will have a RH or RE or mobile base station from main equipment from a mobile operator, and connecting to coaxial cables and using a lot of passive components like couplers and combiners, and then feeding to a ceiling mount antenna. So this is actually a very common, still very popular technology used, especially in the Asia-Pac market. I would say maybe more than 80% of the buildings in Asia-Pac are still using passive DAS. And for one of the reason is cost. Well, that's a very realistic reason. And the hybrid DAS is a combination of active DAS system with passive components at the front end. So basically, the DAS system is going to connect to the mobile base station, the RH, and get an RF signal and amplify the RF signal. And a lot of those systems nowadays actually use fiber connection between the master units to the remote units. And after the remote units, it will connect to a passive antenna and some couplers. So this will be exactly how a hybrid system will be deployed in a building. So then we need to think about when we need to migrate from 4G to 5G building solutions, what will be the challenges and what will be the options. First of all, most operators around the world have already decided to deploy 2x2, at least 2x2, but a lot of them have actually decided to go to 4x4 MIMO, which means you need to have 4 RF paths at the end and 4 ceiling antennas. And if you look at today's passive DAS or hybrid DAS system, it's actually able to support from 2G to 4G all bands, and that's going to talk about very high wide bandwidth. And then if we add 5G and even consider to be a multi-operator, multi-system solution, the challenge that the DAS system is going to face is actually a huge bandwidth, and it's 3 times of the existing one. And then we also need to consider the 5G system will highly possibly be used on the 3.5 or even higher bandwidth frequency band. And lastly, for 5G, we need to support multi-sector deployments in the building. And so previously, a hybrid DAS solution or a passive DAS solution, a lot of them are like single sector or like a minimum selection number of sectors. So those are 4 challenges that we have realized that will be challenges when we migrate from 4G to 5G. And if we do a little bit simulation to see the impact of high frequency band, so for example, if we compare with between 35 C-band versus 1800 megahertz with same ERRP from the ceiling mount antenna, we'll find out the penetration loss. The free space penetration loss for 3.5G is actually a lot higher than 1.8. Yeah, so you can see that there's a 5 dB difference between these 2 systems. And if we do a further analysis using link budget tools for a total loss comparing between 3.5 and 5G versus 2.6 LTE, we'll see if we deploy a 3.5G DAS system, we're going to face around 6 dB penetration loss, comparing to 2.6. And if we deploy on a higher band, on 5G, we're actually going to face around 12 dB loss. Well, there have been a lot of study analyzing how do we penetrate, how do we enhance the coverage, performance, and also capacity when we migrate to 5G. Basically, there are a few ways that we can improve. So for example, we could upgrade the DAS antenna and passive components of the existing DAS system to support the higher bands. We could use 2x2 or 4x4 MIMO, but that means a higher deployment cost, right? And also it will be difficult to manage the gain for each antenna pass to be equivalent. We could also use a higher power 3.5 5G RH, but then the simulation told us you have to reach maybe around 2 by 100 watt, which is actually difficult and challenging for the 3.5 because the PA pallets, the PA chipset is not available to support this high power yet. And of course, you could, if we have an existing active DAS system, we could do a swap, a simple like modularized upgrade to upgrade the existing DAS system to support higher bandwidth, higher frequency band. So if we look at DAS or in-building wireless solution migration paths, starting from the very beginning, this is mainly talking about the technologies. Starting from the beginning when we only use passive DAS, as I explained, and then we have hybrid DAS, but most of those radio units and DAS system is actually using analog technologies, and then migrating to digital DAS, which gives a lot of benefits. For example, the cascading, the coverage expansion capability. And also, when we use digital signal, we can actually do a lot of filtering, capacity routing. So there are a lot of capabilities when you migrate from analog to digital DAS. And then the next phase, we actually introduce active antennas, which means previously the remote radio units of a DAS system is purely just amplifiers or filters. And you still need to connect to an external passive antenna. But the new radio system, the new DAS system, actually we're using more like an active antenna, so you actually integrate the PA and also the radios inside the antenna, so it will become like a wholly integrated antenna system. What we are right now facing a lot of projects that we are working on actually involves 4x4 MIMO, which is very challenging. But at the same time, in the meantime, there has been a new solution proposed for in-building coverage, which is using small cells. So starting from the 3G era, so basically the industry have been ready to propose standalone small cells, or sometimes people call it femto cells. But then, there are challenges facing when you deploy a lot of femto cells in the building, the coordination, the interference, mitigation, a lot of those challenges were actually experienced by a lot of operators. And then a new solution based on the standalone small cells was created, which we call it distributed light RAM or light small cell. So basically what you can do is you have a lightweight baseband processing unit and you connect to a extension unit and then an active antenna head. It will be like a mini BBRH type of architecture, but it gives you more flexibility and lower cost, especially for in-building coverage. And it's interesting to see that for both trends, we're talking about this as a DAS trend, and this is a small cell trend, right? All of them are going to the same direction, which is Open RAN. So what is Open RAN? I borrowed this slide from China Mobile. So Open RAN basically have two objectives. The first one is to reduce the total cost of a network deployment through virtualization. So a lot of you are familiar with 5G architecture. So including the CU, the centralized unit, and distributed units of 5G are going to be virtualized. They're going to be based, will be software based on a standard hardware, a computer server. And the second initiative of Open RAN is to have open interface and even in open source software. So basically all the interface that's defined here between the distributed units to the antenna units, and between the DU and the CU, and even like between CU to the big data AI machine, and also mobile edge computing machine, will all be open interface, so that operators can bring in more competition and vendors into the game. So for example, there are a lot of details described, and I'm not going to go through all those details. So basically, if a small cell vendor that is working on active antenna units plus a part of the DU, and they can actually work together with the CU from a main equipment vendor, and there won't be any challenge anymore because all the interface will be open, and interoperability tests will be done by the operators. So Open RAN, the idea of Open RAN is actually nothing new. If you heard about TIP by Facebook, they have several groups that really works on the open source and virtualization and open interface for the front haul. Front haul is actually here between DU and AU and RH. So there has been a lot of discussions. And there's another organization called XRAN, and it's also talking about very similar ideas. There's also a concept called Cloud RAN. So basically all this different concept was trying to achieve the same target. And Open RAN is a new organization that is going to be set up officially, I think this year. Yeah, a lot of operators are driving it really hard. So as a summary, like we talk about the challenges, we talk about the migration paths. So what will be options like for operators to roll out 5G in building? We analyzed, we put all the different solutions because it's not going to be a one single solution. It would definitely be a hybrid or like a headnet kind of deployments. So we put them onto 3 scales. For existing small to medium buildings, which already have a kind of a DAS system, either passive DAS or hybrid DAS system. The most cost-efficient and fast way is actually to upgrade existing DAS, upgrade the passive components to support higher bands, and also if you're using an active DAS system, get a modular swap to support higher bands. Well, the beauty of this solution is definitely lower cost and moderate, but you get what you pay for. So you have a moderate performance. You won't be able to achieve the peak rate for 5G. But it will be a fast way to achieve, an indoor coverage for the higher bands. And when we look at a higher kind of profile buildings, existing medium to large buildings, the solution that might work will be because for this kind of buildings, people are not just expecting coverage, but also capacity. So a very reasonable solution will be an overlay of 5G distributed RAN, light RAN, small cells, overlay the existing DAS solution in the building. And finally, if operators are facing a new building structure, either large building or small buildings. For large buildings, a lot of large buildings these days, like big venues and big train stations, airports, are actually looking for a multi-band, multi-operator type of solution. So the best way is to upgrade to a 5G and multi-band RAN to carry 5G on a high band and also legacy networks, which can give you the best performance and also the highest cost. And alternatively, for a smaller kind of building, a new building, we can choose this either passive DAS or distributed small cells that can cover maybe 5G on the high band and legacy network. So you get compromised performance, but you also pay less for the deployments. And another option for discussion, and a lot of operators are actually discussing that options, is to refarm some of the LTE bands for 5G users. So basically, most of the DAS, existing DAS, especially passive system, can already support it. You just need to swap a radio, like a base station, and you can have 5G immediately. And Comba, we are, as I mentioned, in building experts. So we are geared up to support 5G evolution by providing a coverage and a light system. We have our Comba iCell distributed small cell system that supports from existing 4G to upgrade to 5G when you need to add a baseband, a switching unit and a baseband units for 5G NR. And eventually, we're going to have a combined integrated units. So when a lot of times the challenge for in-building deployment is not really the equipment, but also the cables, the layout, a lot of effort over there. So when we deploy 4G existing LTE small cell, distributed small cell systems, we put an extra fiber over there. So it's actually reserving for 5G. When our 5G system is ready, we can just plug in. So avoiding a lot of cabling work. Another solution that we will provide for high capacity large venues will be a Complex Pro pre-5G DAS system that actually supports more sectors and multi-bands, and is actually also using active antenna units. At the baseband level, we could either do a DU, so will be a higher power, higher capacity DU comparing to a small cell. Well, we could also, if the operator has an existing base station from another vendor, we could also do a DAU, which is a interfacing a DAS unit that interface and couple the RF signal from the base station, and then transmit and convert to the DAS system. So both options are available. And lastly, talking about Comba, we have more than 80 point of presence globally, and our revenue number is more than 700 million US. We're listed in Hong Kong. We actually are ranked #1 DAS vendor in APAC. A lot of operators here in Asia Pac and globally are our customers. We have 4 R&D centers. We also have, we're actually ranked Tier 1 base station antenna vendors globally. A lot of project reference, especially the railway and the tunnel solutions, and also large venue solutions, so for your reference.